All right, so the other side of this, polyatomic ions, we looked at these right before break. Polyatomic ions, different prefix, we're looking at ions that are made of more than one atom. So these are the newest ones that we've worked with, things like nitrate or phosphate or carbonate. You may be a little bit less familiar with these, but take a look at some of the assignments we have looked at before, and you have those to reference at least for now. So we'll do the same type of stuff. Naming, again, pretty straightforward. Honestly, these are a little bit easier, even though they may look a little bit more complex. We have our cation name never changes. Sodium is still sodium. It starts with Na. You can find it on the periodic table. But then you have NO3, we have this other ion made of both nitrogen and some oxygens. So this is where, for now at least, you've got to look these up. NO3 as an ion, hopefully you find it on your chart. This is nitrate. But once you find it, you don't need to change its name. Its name is nitrate, that's what it is. It's not too bad. We can look at another one here, maybe something a little bit more complex. So we have NH4, which is weird because it's going first, but it's not a metal. And we have Br, so NH4Br. NH4 is one of the polyatomic ions. It's the only one that's a cation. And if you look for it, it is called ammonium. But it's bonded to just a single anion. You know, bromine is just one element. It's not made up of more than one. So we have to use the rule before. This is going to be ammonium bromide. So when you have just that one element in the anion, second part, you know, we still got to do that ident. So that isn't going away. It's the rule we had before, saw it. Hopefully you watched the previous video. So on the other side of this, going to formula writing, maybe a little bit more complex. We will look at first one here. So getting the name calcium, phosphate. So calcium from the periodic table, you look it up, it's in group 2. That means it's going to have a positive 2 charge as an ion. Phosphate is one of our new polyatomic ones. Phosphate is PO4, so 4 oxygens, 1 phosphorus, and that has a negative 3 charge. So the charges here do not match up. Positive 2, negative 3, we have more negative than positive. So we are going to have to cross these over, which means this 2 is going to have to come down here. This 3 is going to have to come down here. So that means we're going to have 3 calciums, Ca3, and then 2 phosphates. So we can't get rid of that 4. That's part of what makes it phosphate, but we're going to have 2 of them. So if you're looking at this and you might think this doesn't look quite right, I get it. Right now it looks like there might be 42 oxygens when you know there should only be 4. This is one other little thing where we're going to use parentheses to show, hey, we've got 2 of that phosphate ion, not 42 oxygens on 1 phosphorus. And so now we've got our formula, and that checks out, and that looks good. So we're not always going to use the parentheses. We're going to look at one more example. So we've got, what do we got here? Sodium. Hydroxide. So another case, sodium is our metal. Sodium we've already seen, it has a +1 charge. Hydroxide is one of our new polyatomic ions. It's an anion. And hydroxide has a -1 charge. So this one's pretty nice. +1, -1. They balance out. We don't need more than 1 either. So we're going to have Na, OH, 1 of each. We don't need to put any parentheses or any additional subscripts or anything. And we are good. for the most part the same as the binary stuff. Just pay attention to the parentheses. That's pretty much it.